When I first started recording these videos, it was July and I was refusing to turn on the air conditioning and it was so hot in this room. And now it's October and guess who's not turning on the heat? It's fine. Who needs heat, right? Okay, so in this video we're going to be doing an actual significance test. In the first video of this chapter you saw kind of the basics, like all the parts, but now we're actually going to be doing one. This example is based on American Idol, which I realize is not the hippest show on TV. Is it even on TV anymore? I don't know. But I don't know. We're going to do it. Why don't you take a moment, pause the video, and read through the question yourself. Before we start this test, let's figure out what it is we're trying to find evidence for or against. They're asking, is there convincing evidence that there is an advantage to going last? Now, our null hypothesis is always the status quo, the thing that we assume is already true. We're trying to find if something else is actually true. So, since we're trying to find evidence if there's an advantage to going last, our null should be that there's no advantage. So that means our null should be that it doesn't matter which place you're in, and that would mean that the fan is basically just randomly selecting someone to win. So since there's 12 videos, we could say that 1/12 or 1 over 12 is the probability that the last contestant is the one that the fan picks. So, this is a lot of rambling to get to the point. The null hypothesis is going to be that p equals 1/12, which I'm going to write as a decimal just for simplicity's sake, 0.083. The alternate is that p is greater than 0.083. Now, this is pretty useless unless we say what p represents. So in your state step, you have to include your null and your alternate hypothesis, but you also have to say in words what your proportion is. So I usually phrase it like this, where P is the true proportion of fans who pick the last contestant. If you want to, you could write out your null and alternate in sentences. Here the null would be the true proportion of fans who pick the last contestant is 1/12 or 0.083. Alternate would be the true proportion P of fans who picked the last contestant is greater than 1/12 or 0.083. Your teacher might tell you to do something different. I'm okay with just null and alternate in symbols and then a sentence saying what your parameter is. If you didn't say where P is the true proportion of fans, I would mark this wrong, because how am I supposed to know what P represents? It's also a good idea in the state step to say what your significance level is. It would be considered cheating to do the entire test and then go back and decide what your significance level was. So we'll use 0.05, that's kind of our standard significance level. The plan step is going to seem very familiar after we did confidence intervals. We have the same 3 conditions. So we start off, it doesn't matter the order, but I'll start off by saying the fans were randomly selected. And if the random condition is met, that means we can generalize our results to the population, which obviously we want to do. The second condition I'll check is independence. We can assume that there's more than 6,000 fans. No, that's mean. There's definitely more than 6,000 fans, right? There were more than 6,000 fans back in the day. Back in the day when I would pick up the phone that was attached to the wall and call in to vote for the contestant, there were more than 6,000 fans. If we meet the independence condition, that's good because it means we can use our formulas. And last but not least, everyone's favorite condition, the normal condition. Now remember, with proportions, we're checking NP and N1 minus P. So because this whole significance test is based on assuming that the null is true, I'm using P here. So I'm using 0.083, the proportion from the null. So 600 times P and 600 times 1 minus P, both of those are easily greater than 10. So the sampling distribution of P hat is approximately normal. And that's good because it means we can use Z star. Now everything I have in parentheses here, technically you don't need. You do need to use a full sentence. So for the normal condition, personally I would give you partial credit if you said it is normal. Because what is normal? I have no idea what you're talking about. The test is normal, you're normal, I'm normal. We know that's not true. So you have to say what's normal, specifically the sampling distribution of P hat. But what I have in parentheses is more of the why we're checking those conditions, and I don't need to see that. I just wanted to write it in as a reminder. Okay, now I like to draw a quick sketch. Here's our sampling distribution. It would look like this if the null were actually true. It would be normal, like we said, and the mean of the sampling distribution would be P. This whole significance test is based on the assumption that the null is true. So the mean of p hat here, or the mean of the sampling distribution of p hat, would be 0.083. Before we go on to the do step, let's just calculate the standard deviation of the sampling distribution. Once again, I'm going to use p, and we get 0.0113. Okay, it's a hefty plan step, but it is really important, and it's going to make the do step so easy because we've done half the calculation already. So first things first, we need to figure out what p hat is. 59 out of 600 fans chose the last contestant. That's 0.0983. So that's our p hat. Before we go on, we can just mark where that is on the diagram. A little bit above the mean. The question is, how far above? Oh, I almost dropped that in the coffee. Oh, and you know the pen that goes with this tablet is like on back order for months right now. Okay, everything's fine. So if we want to figure out how far above the mean this p hat is, we're going to need a z-score. It's generally best practice to write out the formula like in general first. So for z-scores, that's statistic minus parameter over standard deviation of statistic. So p hat minus the mean of the sampling distribution of p hat over the standard deviation of the sampling distribution of p hat. Then you can plug things in, and we get a z-score of 1.35. So our p hat is 1.35 standard deviations above the mean. Now it's not enough to just know how far above the mean our p hat is, we also need to know the likelihood that we would get this particular p hat or something more extreme. So for that, we need a p-value, which is really just this area that I shaded in. So we're going to use norm CDF because we know that this is a normal distribution or approximately normal. My lower limit is 1.35, upper limit is 1,000. And then I'm just using 0 and 1 for the mean and standard deviation, and there's our p-value, 0.0885. Okay, now the whole point of this was to make a conclusion about whether or not we have good evidence against the null. So here's my conclusion. It's color-coded, and I'll explain those colors in a moment. Wait, before there's a typo. Yikes. Okay, here's our conclusion. The probability of getting this p hat or something more extreme if the null were actually true is 0.0885. This is larger than the significance level of 0.05, so we fail to reject the null hypothesis, and we conclude that there is not convincing evidence that there's an advantage to performing last in American Idol. Okay, we just did 3 things in this conclusion, and you always have to do these 3 things. In blue, we interpret the p-value. This just means we explain what the p-value actually says. Now you can always use this same format when you're explaining the p-value. A p-value is the probability of getting this particular statistic, in this case it's p hat, or something more extreme, if the null were true. That part is actually really important. If the null were true. The whole idea of the p-value is it's telling you the probability of getting a certain p hat under the assumption that the null is actually the truth. So you have to say if the null were true. Now there are certain years of the AP test where they say that interpreting the p-value can just be you saying the p-value is greater than 0.05. I don't understand the years where that's part of the grading system because that's not really interpreting the p-value. So I'm always going to require that you say the actual interpretation of a p-value. It's the probability of getting this particular statistic or something more extreme if the null were true. In red, it's the decision. You have to say if you're going to reject or fail to reject. I mentioned both of those in the last video. Since our p-value is bigger than 0.05, it's not very convincing evidence. This could happen by chance. It's not that rare that we would get this particular p hat. So we fail to reject the null. And then green, you have to include context. So don't just say fail to reject the null, period, done. You have to go back and actually look at the problem and see what were you talking about in the first place. So here we say that there's not convincing evidence that there's an advantage to performing last in American Idol. No matter what problem you're doing, just make sure you refer back to the scenario so that you get points for including context. Now, I don't want this video to be a million minutes long, so I'm not going to do all of example 2 in this video, but I do want to point something out. Why don't you pause the video and just read through this scenario. Notice that in this problem, we're asked if we have convincing evidence that the proportion of all employees in this chain who would say yes differs from 0.75. I just want to point this out as a reminder that it is possible for your alternate to be not equal to. So if you were to do this problem, which I would highly recommend to do, just for some extra practice, P is the true proportion of employees who say yes. Your null is that p equals 0.75, and your alternate is that p does not equal 0.75. So just a refresher, it is okay to have not equal to as your alternate. Keep in mind what that means in your do step. If your p hat is over here, instead of just looking at this tail for your p-value, you have to look at both tails, because you're looking for the probability that you get your p hat or something more extreme in either direction. So in this case, it's 68 out of 100 employees. That's smaller than 0.75, so it's here. But it could be larger too. We just want to know if it's different than 0.75, not less than 0.75. So just something to keep an eye out for. I'll post an answer to the rest of this problem in the description of this video in case you want to look at that. I would highly recommend that you do this problem just for some extra practice.